So this is the demo for Lab 7.2, um, part, part 2. This is the make, driver. So if I type in the word, I don't know, 8, I do 15 times, almost 15 guesses. I do A, S, D, E, F, G, H, J, Q, E, W, R, Y, U, X, V, C. I did get the word. It was ambition, but I guessed the wrong word. So I want to do it again. Let's say I want 5. I want to guess a 5-letter word. I'll cheat. I'll do 26 letters. A, S, D, E, G, H, J, K, L, Z, X, so on and so forth. I got the word. No surprise. So yeah, I'll show my main.c file. So I have a bunch of functions here that handle a lot of the user input and the output. Read words, it just reads all the words from a dictionary and then assigns each word to a separate generic vector based on their length. And init vectors, that just initializes all the vectors in an array. Generate init key, so this generates a blank key in the beginning. I have a myString representing the key in general and like the word that they see on the screen that they're trying to guess. And this generates the first key, which is just a blank key with all hash marks in it. That is the length of the word that they're trying to guess. This requests the word length, so it's just disassemble IO, number of guesses, guess, cheats, replay. So yeah, that's just IO. Already used determines if a character, this function it returns a Boolean value if they already used a character. This is just IO, shows the user what letters they already guessed. This is a full word. It returns true. It returns a Boolean value to true if the word that they're guessing is complete. They've guessed all the letters that need to be guessed. In added, so I only decrement the guess if the amount of guesses they have if they added a character to the the key. So this determines if I should decrement the number of guesses they have left. So yeah, this is length, guess count, guess. This is now the beginning of my. This is where I do my game. The do while loops runs at least once. This is the master key, so it's the key with the greatest number of words possible that I can choose from. So in the beginning it's blank, but then as the game progresses, it adds characters and chooses the right key that has the most amount of characters. I mean, myString's in it, words. So key is just it's used to generate a key for each word. Use letters just keeps an array of use letters that the user already guessed. So this is just all IO. Going down here, now this is one round, this while loop. So I initialize my associative array, which has my hash table and my tree in it, and then for each, so this is just IO handling. So for each my string, for each word that is in a bucket, it's in one for the first round. The bucket is the length of all the words that they're trying to guess. So it goes through all the words in the current bucket, and it generates the key for each word in the bucket, and it also inserts them into the tree and the hash table. So it inserts their key, their unique key, into the ABL tree, and it then takes that and indexes it at the correct index, unique index, with a generic vector. But I'll show you that in the associative array module. So then this function here actually prints out all the it runs through the array. It uses post order traversal, and it prints out all of the elements in the tree along with the my string key, as well as I believe the size of the amount of words in the generic vector that represent one family. So this function here, array reduce tree max, so what it pretty much does is it also does post order tree traversal, and it for every node it comes across, it checks to see if the amount of words in the bucket is less than the index, the current index of words in the bucket, and then if it is, then it swaps them and then it deletes it. So essentially, what this does is it deletes all the nodes in the tree except for the maximum bucket of words, or in this case, generic vector of words. So bucket equals array bucket. So yeah, I'm just setting the bucket to the generic vector that represents the maximum number of words possible. My string is just the key that represents the amount, the maximum number of words possible in the out of the family of words generated. Master key, yep. So that's yeah. So this is just IO stuff. Yeah, just letting the user know how many guesses they have. So yeah. In here, if the managed to have a full word, then it prints out congratulations. If it doesn't, then it prints out this I'm sorry message, and then it prints out a random word that they didn't guess that's part of the bucket. So generic vector destroy. So yeah, it destroys all the it destroys all the MyString objects that I used. So and then this last bit here just deletes all the generic vectors that I created at the beginning. Here in this function, yep, this is the print use letters, so I'm just printing out the letters that they already used, and it's just simple IO. Here is the added function, just it returns a Boolean value to see if the word was added to the string, so I know whether or not to decrement the amount of guesses they have left. Here is another function that returns a Boolean value, turns to see if the word is complete. They've guessed all the letters that need to be guessed for the word to be complete. This is read word, so yes, this is just IO. Initialize this array of vectors, yep, already used. Again, this is a returns a Boolean value if they already guessed, if they use a letter that they already guessed previously, then it will return 1. But if it's a new letter that they already are going to guess, then returns false. So yeah, this is just IO, just the game's IO. Request guess, request replay. Yeah, so this just generates the blank key I was talking about in the beginning. Alright, so this is the associative array module. So I think this is a pretty big module. But yeah, so I have the struct node represents the tree. So this hash table, it's storing a generic vector, one generic vector, and my string. So this my string represents the string string version of the key with the hash marks in it, and this represents all the words that fit this key. So yes, and then the struct array. So it just holds one. It holds a node. Holds one tree, and then holds a hash table, and it keeps track of the size of the hash table as well as the index where the maximum number of words are in a family. What family has the maximum number of words. So yeah, this has a lot of functions. So int hash, so yeah, that just generates a random integer. Pretty self-explanatory. Create a node, insert node. These are tree operations. Get height, get balance factor, find max, all used for helping in inserting a node. Right rotation, left rotation, same deal. Delete leaf, find min, that's used in deleting a particular node in the tree that has a key, a certain key. Void service print, so that's aiding in printing. I believe it was in order traversal that I printed them out. Find max index. So yes, this helps in finding the maximum family word tree the word tree that has the maximum number of words in it. Void surface reduce. So yes, so this helps in reducing the tree so that it only has the generic vector that holds the maximum number of words inside. So yes, this is the associative array init function. So initializes associative array, and it initializes all the the generic vectors and the my strings inside of the hash table, as well as set the root to null of the tree. It also of course, if it, when it's allocating space, if it's null, then it just returns null. So this is array insertion. So this is going back to the main function. This is where I call this right after I generate a key from the word in the bucket. So it requires a associative array object, my string word and my string key. The word is of course the word that is in the bucket, and then the key is the key that fits the word that fits the key. So in here I'm pretty much just adding, if it doesn't exist, then I'm adding it to the hash table at the given index, which was generated by the hash function in this module. And I'm also adding the key into the AVL tree. Array print, so yes, these two functions help in printing out all the, so I'm using, I believe I was in order, sorry. yeah, so these two functions help in printing out all the nodes in all the information in the tree. Um, this reduce function again. So these next two reduce functions, they what they're doing simply is just reducing the tree um, to just so that the root of the tree holds the generic vector with the maximum number of words inside of it. So this just deletes a single node. This finds the minimum key value in the tree. Get max key. So yeah, so this this get max returns the generic vector. So it creates a generic vector and sends it back so that the bucket can get updated in the main function, and it can continue on with the bucket with the most amount of words. My string, so yes, that's these two work together almost. Well, they don't, but they this one returns the bucket value, so the value that the bucket should be, and then this returns the master key, so the key that the master key should hold in the main.c file. So, yep. Oh yeah, so this is the hash. This is the hash function. So it generates a random integer, a unique random integer for a given key, and it just multiplies by a random constant, which is 5, and then it multiplies it by the index that holds a hash mark. So this is inserting a node into the AVL tree. So again, the AVL tree is holding all the unique keys that have been generated from a bucket. Create node again helps in the insertion of the AVL tree. Get height. All these functions are helping in inserting a node into the tree. Right rotation fixes the tree if it's the bounds factor is not the 1 or -1. Same with the left rotation. So yeah, that's about it. Oh yeah, I'll just show you my associative array.h file. So yeah, I have all these functions here that are accessed by the main file. Yep. And I think that is about it. Let me just Alice, is there anything else I'm missing? No, I think that's about it.